Hi everyone, I'm Leslie Huey. I'm an associate professor of urban and regional planning, and I am introducing Jennifer Blesh. Jen is a soil scientist and agroecologist. She has many accolades, but I'm going to focus on, besides being an associate professor in the School for Environment and Sustainability, that she is an amazing mother. She is an amazing baker, a committed yoga practitioner and friend. And this is one thing some of you might not know about her, but she is one of the few people who can say they hiked the entire Appalachian Trail in sneakers, which is, I think, pretty impressive, especially impressive. Asked about her favorite food, Jen said, given my love for legumes and that it's the tail end of winter, anything with beans, especially bean soups, and a favorite this month is split pea soup.
I didn't know you were going to learn all of those facts about me tonight. Okay. So soil holds the largest stock of organic carbon on land. This is 3 times more than all the carbon in the atmosphere. Nearly half of global soils are cropped or grazed, and most of these soils have lost around 50% of their topsoil carbon, mainly through decomposition and release as carbon dioxide. But improved soil management can reduce emissions and also return CO2 to the soil. And the biggest opportunity for sequestering carbon is restoring soils that have been degraded by industrial agriculture, which has low crop diversity and bare fallow periods that reduce soil carbon. Sequestering carbon relies on plant photosynthesis to take up carbon dioxide, along with management practices that increase the proportion of that carbon that ends up in soil organic matter. Long-term experiments around the world show us that this is best achieved when management is based on principles of ecology. So more crop and livestock diversity, perennial species, low or no external inputs, and reduced soil disturbance. But this holistic ecological perspective is often missing. Instead, carbon offset schemes include many management practices that are not all created equal, and they don't always consider the complete management system, which determines the actual effects of those practices and could lead to unintended harms for, say, water quality or biodiversity. The commodification of carbon also has huge social inequities. In private and unregulated carbon markets, the biggest agribusinesses get to define what a climate-smart practice is, which means that industrial farms are more likely to receive carbon payments and polluters can buy credits for practices with uncertain outcomes. So speaking of uncertainty, in case you didn't know, it's really hard to predict how much carbon can be sequestered in soil. And this is just a few reasons. Controls on carbon are truly biogeochemical, and complex interactions between those factors and farm management determine the potential for carbon storage in soil. Related to this, we've recently had a huge paradigm shift in the field. So our understanding of how carbon is stabilized, especially the role of complex plant-soil microbe interactions, is emerging. So this means that soil carbon models don't accurately capture these processes. There's also high spatial variability in soil, even in one field. So on top of that, about half of the organic carbon in that field isn't easily affected by management. And as those in my lab can tell you, that means we need many samples and long time frames, usually five or more years, to be able to detect a signal of increasing total carbon. And then finally, organic matter has a pretty consistent ratio of carbon to nitrogen around the globe, so it's not clear how much nitrogen would be needed to restore soil organic carbon and potential trade-offs for emissions of, let's say, nitrous oxide. So many scientists are skeptical of these simple, straightforward programs. The claims like this, that companies offering carbon credits can assess soil carbon reliably on a year-to-year basis, which is how the payments are made. Not to mention the problem that by definition, soil carbon sequestration is reversible. It can be undone if we change management. But the large-scale assessment models that are guiding climate change policy assume that these negative emission strategies are ultimately going to play a large role in us reaching the 2°C target. So I would argue we need to get it right because the stakes are too high. We can't risk offsetting fossil fuel emissions using these current approaches to carbon trading in agriculture. So how do we improve these outcomes? Through an agroecological perspective, you won't be shocked to hear me say if you know me. And this is very different from commodifying just one chemical element. So instead, it seeks to achieve multiple goals from farming systems. And credible science shows us that rebuilding soil carbon improves many different functions that can increase productivity, resilience, and much more. So rethinking soil carbon sequestration as central to a wider set of goals is more likely to achieve climate change mitigation and also benefit livelihoods, especially those of farmers in the global south who are much more vulnerable to the shocks that will be coming from climate change. And the good news is there are actually many indicators of sustainability that we can measure much more easily and reliably. I just listed a handful of my favorites here to illustrate that, as well as a nod to a CNAP project we have measuring one of those. There are also known policy pathways that can get us to multifunctional soil management. Those include improving antitrust laws to reduce excessive corporate power that currently constrains diversification, targeting cost share programs so farmers can have greater access to land, credit, knowledge, seeds, et cetera, regulating environmental pollution, and then finally, this need to invest in participatory research so we can co-create food systems that are based on sovereignty, traditional knowledge, and ecology. So I am really thrilled that people are tuning in to the power of soil again, but we need to reconsider allocating massive resources toward unregulated markets for one of the hardest soil properties to measure. Instead, soil carbon sequestration should be one of many benefits that come from transforming food systems toward agroecological practices. Thank you.